Non-foliated metamorphic rocks do not have preferred mineral orientation. When we look at non-foliated rocks, we're going to see something that looks a bit more massive. Rather than having any sort of orientation like alignment of crystals, we're looking at just a big, massive chunk or something that's what we call more homogeneous, the same throughout the rock as a whole. Non-foliated rocks do not have preferred mineral orientation for two reasons. Either there was a lack of differential stress, or the minerals have an equant shape. So if the rock is squeezed the same from all sides, the minerals are not going to line up according to a different stress. Also, if they are more equant in shape, the mineral grains, they don't line up according to stress. They just roll and kind of move to change how they're sitting, but we don't get any sort of preferred alignment. Now, when we look at non-foliated metamorphic rocks, there are going to be far more that exist on Earth than what we're looking at in this video. In this video, we're going to look at 3 non-foliated metamorphic rocks that are the most common and easiest to identify. But if you are interested in non-foliated metamorphic rocks, be encouraged to look online for others that exist, because again, we're only covering the sort of most common or simplest to identify of these. The first is quartzite. When we look at quartzite, we're looking at a more metamorphic rock that has quartz sand-sized grains that have recrystallized from the protolith to make interlocking crystals. So when we hold quartzite and we look at it, you can see on the surface things that are about sand-sized in shape, especially along this fractured surface. You can see them kind of shining back at you, sand-sized again, but when you feel it, it's very, very smooth. The reason is the sand grains in the protolith that had space between them, they didn't align perfectly because they're rounded in shape, so there's little gaps of air in the rock between the grains. You can feel the grittiness in the sandstone. Because of the heat and pressure, those grains have recrystallized and are now interlocking within the quartzite, making that nice, smooth feel to it. Just like in this sandstone we have ripple marks on the surface, we can retain characteristics of the protolith, like we see ripple marks in this rock, in our non-foliated metamorphic rock, in this instance, quartzite. The next non-foliated metamorphic rock that we're going to look at is marble. And when we look at marble, we're looking at metamorphosed limestone or dolostone, so sedimentary protoliths, that again have recrystallized grains from their origins. So when we look at marble, we can see crystals shining and bouncing light back to us. Again, these started in the protolith, this sort of different grains that because of the heat and pressure have recrystallized to become interlocking. Again, it feels relatively smooth. Now, quartzite and marble can look extremely similar in appearance. So how can we distinguish between quartzite and marble? The great thing is quartzite contains quartz, which has a distinguishing characteristic when compared to marble, and calcite and dolomite, that it is hard enough to scratch glass. Marble containing calcite and dolomite will react with hydrochloric acid, which quartz will not do. So when, again, we're looking at these, our marbles and our quartzite, these look a little bit different because of their color, but again, they can look extremely similar when we see them out in nature. Quartzite, again, we have our glass plate, is hard enough that it will easily scratch the glass, whereas marble, when we put acid on the surface, will effervesce or have a reaction. If we see effervescence like this, very vigorous, we know that this marble has a limestone parent because limestone contains calcite. Calcite reacts vigorously with dilute hydrochloric acid. If we put acid on the surface of the quartzite, we're going to see no reaction whatsoever. It sits there, there's no bubbling, nothing going on. If we put the acid on a marble that has a dolostone protolith, we see no reaction. We need to remember, or you need to remember while you're working on these, that dolomite unlike calcite, needs to be powdered to effervesce. So we take the metal nail, we scratch to make a powder, which again is a giveaway for this not being quartzite, because quartzite would not scratch with a metal nail, it's too hard. We then put the acid where we have the powder, and it might be hard to see in the video, but we are getting effervescence or bubbling where we made that powder. So if the marble needs to be powdered in order to effervesce with hydrochloric acid, we are looking at a dolostone protolith rather than a limestone protolith. The last non-foliated metamorphic rock that we will look at, again there are several more, but this is the last that we will look at the introductory level, is metaconglomerate. Metaconglomerate, as the name would obviously give away, is altered conglomerate. Typically in a metaconglomerate, the gravels have been deformed, they're sort of flattened and become oval shaped, and the cement or matrix surrounding the gravels is typically weaker, so it has recrystallized to make a much stronger rock as a whole, and the gravels are typically fractured through rather than in the protolith conglomerate we have breaking around the gravels. So looking at the protolith conglomerate, we can see again the gravels are protruding, they're not broken through. It would be more likely to break around the gravels because that weaker cement or matrix surrounding it. So we could pluck these gravels out relatively easily versus when we look at a metaconglomerate, we can see here the rock as a whole is much stronger, much more durable because that cement or matrix has recrystallized, and then because the rock as a whole is stronger, the gravels that again are deformed in shape, sort of oval shaped as we look through here, are broken across or through. So they're not really protruding or sticking out like they were in the protolith. Now they've been compacted more tightly into the rock, and when the rock breaks, it breaks through the gravels rather than having them protruding or sticking out from the surface. These are the non-foliated metamorphic rocks that we will look at in the lab. Again, if you're interested, look online. There are far more than what was talked about in this video, but at the introductory level, hopefully these are a good guide for you into the non-foliated metamorphic rock group.